So we've taken a look at algebraic proofs, so now we're moving on to geometric proofs. And when writing a geometric proof, you use deductive reasoning to create a chain of logical steps that move from the hypothesis to the conclusion of the conjecture you are proving. So in a little diagram here, you're starting with the hypothesis, and you are using definitions, postulates, properties, and theorems to work your way to the conclusion to prove that it's true. So for example 1 here, it says write a justification for each step given that angle A and angle B are complementary and angle A is congruent to angle B. So looking at that picture over there, those are the angles we're talking about. And number 1 says angle A and angle B are complementary. Well, that was in our statement up there, it was given to us. So we can just say given. Then we look at number 2 that says the measure of angle A plus the measure of angle B is equal to 90 degrees. That is the definition of complementary angles because that definition says that when we add two angles together, we get 90 degrees. So our proof for this is the definition of complementary angles. Number 3 says that angle A is congruent to angle C. And if you look up above, that was given to us as well, so we can just say given. Number 4 is the measure of angle A is equal to the measure of angle C. That would be the definition of congruent angles because it says that two angles are equal. So definition of congruent angles. And you can write the words out or you can use the symbols, whatever works best for you. Number 5, the measure of angle C plus the measure of angle B is equal to 90. That is the substitution property of equality because we used steps 2 and 4 here. Step 2 said measure of angle A plus B is 90. And 4 said that A and C are equal. So therefore, I could substitute in number 2, the measure of angle C in for A. Since they're the same, I can switch them out or substitute them out. So, and they're equal, then we can say that C plus B is 90 degrees using the substitution property. And then number 6 says that angle C and angle B are complementary. So if in step 5, if we add them together and we get 90, then we are using the definition of complementary angles again. A theorem is any statement that we can prove. And right here we have two different theorems to look at. The linear pair theorem says if two angles form a linear pair, then they are supplementary. So our hypothesis and conclusion are that angle A and B are supplementary if they form a linear pair. Congruent supplements theorem, if two angles are supplementary to the same angle or two congruent angles, then the two angles are congruent. So if angle 1 and 2 are supplementary, then angles 2 and 3 are supplementary. And from that, we can gather that angles 1 and 3 have to be the same because both of them work with angle 2 to create supplementary angles or create a 180-degree angle. So a geometric proof begins with given and prove statements, which restate the hypothesis and conclusion of the conjecture. So we're going to use a 2-column proof, which is listing the steps of a proof in the left column, and you can write the matching reason for each step in the right column. So example 2 says to fill in the blanks to complete a 2-column proof of a linear pair theorem. So we are given that angles 1 and 2 form a linear pair, and we have to prove that angle 1 and angle 2 are supplementary. So using the statements here, we have to fill in the missing. So they start with angle 1 and angle 2 form a linear pair because that was what's given to us, so we have to start there. Then looking at that, if they form a linear pair, they form a straight line, then ray BA and ray BC form a line. So if angles 1 and 2 form a linear pair, that means they form a 180-degree angle, then those two rays are going to form a line. And that is the definition of a linear pair. And number 3 is the measure of angle ABC is 180 degrees. Well, if they make a straight line, then that angle is 180 degrees. So that's the definition of a straight angle. And then for A, we have to figure out what's missing here. And we can look over here at the reason, and it's angle addition postulate. So we have to move from step 3 that says the measure of angle ABC is 180 degrees. And our next statement has to deal with adding angles together. So if I know that, let me use a different color here. If this angle is 180 degrees, then this angle plus this angle would make 180 degrees given this information that ABC was 180. So we can go ahead and fill in that the measure of angle 1 plus the measure of angle 2 would be the measure of angle ABC. And then part B is saying that we have to use substitution. Our reasoning over there is substitution. So we're going to have the same thing, except for now we know that the measure of angle ABC up here they told us is 180. So I can replace that with 180. So that's just substituting that in. And then step 6, angles 1 and angle 2 are supplementary. So we have to figure out the reason. How do we know that that is supplementary? That is by the definition of supplementary angles, because that's telling us what a supplementary, or what two angles that are supplementary mean. Then we have two more theorems. We have the right angle congruence theorem, where all right angles are congruent. So if angle A and B are right angles, then we can conclude that angle A is congruent to angle B because they're both 90 degrees. And then we have the congruent complements theorem. It says that if two angles are complementary to the same angle, then the two angles are congruent. So this is very similar to the congruence supplements theorem. Now we're talking about complementary angles instead of supplementary angles. So if angles 1 and angle 2 are complementary, angle 2 and angle 3 are also complementary, because then we can conclude, that angle 1 is congruent to angle 3, because angle 2, each one of those with angle 2 forms complementary angles, or a 90-degree angle. So example 3 says to use the given plan to write a 2-column proof of the right angle congruence theorem. Given angles 1 and 2 are right angles, and we have to prove that angle 1 is congruent to angle 2. Our plan is to use the definition of a right angle to write the measure of an angle, of each angle, and then use the transitive property and the definition of congruent angles. So they kind of give you stuff to work with here. And we're going to start off with our given. Angle 1 and angle 2 are right angles. And that is what is given to us. So here's my 2 columns. Then If angles 1 and 2 are right angles, then we know that they are both 90 degrees, since right angles are 90 degrees. Oops. And we know that by the definition of what a right angle is. My goodness. And if they're both equal to 90 degrees, then they must be equal to each other. And we know that because of the transitive property of equality. Finally, if the measure of angle 1 is the same or equal to the measure of angle 2, then angle 1 must be congruent to angle 2. And that would be because of the definition of congruent angles. So as you can see, all of these definitions are very important to have and to keep. So make sure that you are not losing these notes and that you're keeping these all written down in a safe place, preferably together, so that when it comes time for test day, you have everything you need right in one spot.